Yes, we are actually running how to fit the data using first order lake law, and also we are running what is the steady state and non-steady state condition to solve the environmental problem. Well, this is one example I have shown last class. Label plot. This is label plot, or this is just like one big fat cake. As a lake, the contamination of the fishes in the lake is so, serious actually. The problem is, I don't even know. Do you usually get fish? Well, I think I'm some European style. I mean, the cuisine is, But this, when I was student, graduate student in the United States, it is just like most of the people there, hate the eating fishes. It is just like eating the flax or eating the snakes. I really don't know why they, eating fish. Well, anyway, as I already talked, EPA. Environmental Protection Agency of the United States actually recommended to not eat one salmon steak per month because salmon actually can. Well, have you ever tried to have salmon steak? Is it good? For the eater, salmon is very good. The cook, chef, salmon is very not, proper. I mean, it is very difficult to, make steak because it contains high contents of fat. You know that, right? So that means most of the organic contaminants, chemicals, which flew through the air is mostly pesticide. And the mostly herbicide, and those are very water-hate character. We call it what was that? Hydrophobic, right? So hydrophobic chemical compounds, it can easily dissolve on the surface of fat. So the animals which has higher content of fat usually have more serious contaminant problem. For example, the polar bear fat, well, because they need to survive that polar area, they really have very chunk of fat in their belly. So if you take some fat from the belly, and you can find very serious contamination by the contaminants. Well, you can see this fish. As I already told, this is not fish. This is kind of fatful pig actually. Well, anyway, as you can see, you can imagine bunch of hydrophobic chemicals can be accumulated on their, fresh actually. So before eating salmon steak, you need to think about. Most of the Korean people believe eating fish is very healthful, but the truth is, that could be a very healthy food, but it could contain high dosage of contaminants. So how can you say that? So think about the contamination, the contaminants in the food. Now think about one more thing about the apple. Most of the Koreans believe eating apple without peeling is best because most of the people believe most of the vitamin C and most of the nutrients actually in the peel of the apple. That is a lie actually. maybe 30%. The remaining actually stay in the apple. But if you, well, you can say 30% is not negligible, you know. But think about that. If you spray the herbicide or pesticide on apple tree, most of the pesticide and herbicide can be accumulated on the surface of the apple or the stem. You really need to remove stem, you know, very well. That is very, very important. Never ever take a stem. You know what stem is, right? Yeah. Sometimes just nothing her head. Belly part. So remove it because the rectified pesticide can be, you know, accumulated in this side. So if you consider the contamination by the chemicals, you really need to peel out the apple. This is very important. So never ever eat the peel. I mean that. Or if you really want to take it, just grow yourself in your garden. Right? Okay, anyway. Well, you know, we can measure the concentration of contaminant, DDT, in rainbow trout. Ron Heights actually started to measure the concentration of DDT in trout from 1970s, actually. And then he, you know, the concentration like this, right? This is the drop-down curve equation, right? So here, this is the concentration, and this is the time, right? K is rate constant, actually. So Ron actually, the first time, think the DDT can be transported from the southern part of the United States, and then it can accumulate rainbow fish, actually, trout. So he measured it from, as he said, 1970s, and he measured it around the 1990. And he just published this experimental literature in Nature. This is very simple, right? And what he did was, he just, you know, well, actually, he really hated mathematics. So if he can do some more easy way, well, he really find it very well. So what he did was, he just put it, he just do some, you know, arrangement here, and then put the natural law each side, and then make linearization, actually. So he can have NC equals C0 KT. So, well, here, as you can see, here is the time T, and you have the concentration C and NC, right? So you can put the time T and NC fitting, which is actually linearized curve. So as you can see, you can have these two nice fitting. This is for the natural log C, and this is just, you know, concentration with respect to time, right? He just put this to figure in the paper, and then explain some implication. It is very important. Well, you know, everybody knows some experimental data set, but as an environmental scientist, he explained the implication, and then sent it to Nature, and it was accepted mid-1990, actually. Very simple. And you guys, I think I teach you how to publish your paper, your result in Nature, and how to calculate it. And now it is time you start to publish your experimental results. Although you are the undergraduate student. Wow. All right. And then think about the this is very simple way, right? But this is just a drop-down curve. But what we want to do this one when we have, not drop-down, going up curve. How do we do this? Can you use the same protocol for the linearization of going up curve? Can you do this using the same protocol? Well, I think you guys can do this when you get back to your dormitory or to your library. Well, the answer is actually for the outgoing equation, you cannot simply do the linearization, because in this case the equation can be made linear when you know the Cmax is known property, or when you have reasonable proper guess, then you can get this equation like this. Well, do it yourself. Please make this one as a small homework. I think you guys are usually already did the small homework assignment 1, right? As I already talked, the lecture material, this is version 0 of environmental chemistry, actually. I and Ron actually decided not to put the box problem in version 1, actually. But now I find all of the box materials actually in the sample problem of the text. So if you have the book, you can find it. This is already used as sample problem. So you don't have to actually solve the problem because you got already the solution, actually. So please don't do the small homework. I'm not going to give you any small homework from now, right? Please solve this one for chapter 2. Well, chapter 2, you do small homework. But from the chapter 3, you don't have to do the small homework, all right?
When's that due date? So homework, when's that due date? Next Sunday? Or?
Well, today we will finish chapter 2. So that means you can start chapter 2, the main homework assignment, and also small homework 2. The due date is 1 week for small homework, right? All right.
Next Friday is
Well, usually I finish the chapter by Friday, and technically I want to give you the homework. You start the homework from the Monday. So if you want to submit your homework Friday, well, please do so. But you guys have a couple of days more. Yeah, start it from Monday, all right? Okay, as I already talked, you should know Cmax value so that you can have this simple linearization. But I really want you to know how many people here already have statistics. Anybody here? You can raise your hand. Okay, these 2, 3. If you don't have it, please have it. I think statistics are the basic course. Whatever you want to be. If you want to be a researcher, you need to have statistics. If you want to be a businessman, you need to have statistics to earn money. So this is very, very important, right? Well, anyway, if you cannot have this simple linearization using simple gas, what you should do is doing some nonlinear fitting technique. What is the difference between linear and nonlinear time of the fitting technique? Michael over there.
Time of what? I'm sorry.
My question was, can you distinguish what is the linear type of fitting and what is the non-linear type of fitting? No means you don't know, right? Sam? No? Jimin over there.
I can make a guess for like with linear outcomes. I don't know how to say it in English. 힘을 최소화 제곱 차이 최소화하는 그 방식을 쓰는.
Yeah, that is one of the method for the nonlinear regression, risk scale method, right? For the linear risk scale method, there is. Have you ever checked the function hold solver at Excel? I think there is couple of example question in homework too. You really need to use solver, which can do some nonlinear list scale method. I think. Well, you guys already have calculus, right? If so, please have numerical method or statistics. That is very basic of your coursework. You should have it. All right. Now you do small homework. The concentration of chlorostyrene in trout in Great Lakes have been measured over years. Following concentration, estimate the chemical compounds in this fish. Simple. I think this is also shown in the spherical cow. The spherical cow is very intuitive text. All right. Okay. So far, all the environmental problems I introduced you is mostly depend on one chemical compound, right? For example, we just want to calculate, estimate the rate at which radon is removed from one house, right? But the concentration and the rate actually depends only on the concentration of radon in the house, right? So dC over dt equals the concentration of radon. That's it. And the second example was the rate at which pollutant is removed from the lake. This also depends on the amount of pollutants actually. So simply the concentration of radon or the concentration of some chemical compounds in the lake is the rate itself is just proportional to the concentration of radon or the concentration of contaminants in the lake. Right? So as you can see, this is very simple. The prototype is this over dt equals actually minus kc. Well, you can now there is hidden n here. So in this case, what is the value of n? First, the one, right? So we call it first order rate. What about if n is 2? We call it second order. But think about this. Is a reaction occurred in the environment surrounded by us? What is the usual ordinary rate of the degradation reaction occurred in our environment? Is it first? Is it second? Third? Pick one up. What do you think about this? Any idea? Or the same? Well, I just want to know your guess. Just give me a simple guess. You can say 0 first or second. I cannot ask you. I don't ask you. I don't want to ask you the reason why. What was that? What is that? Okay, Adhika, what do you think about this? Second. And I just want to ask you why. Why do you think the second? Just guess. Okay. All right. Well, if you think you are the engineer, you really want to solve the problem very exactly, right? You don't want to allow very simple assumption because you are brilliant, you are talented, you know the theory. So you just want to solve the problem as it is without any, assumptions, right? That is what engineer want to do that, solve the problem. Think about that. If you just put huge amount of the assumption for constructing the building or constructing the bridge, what happened there? Most of the people don't want to, across the bridge or don't want to stay in the building, actually. Why? We just want to have safe building, right? To solve the problem, engineering problem. What about the environmental problem? Do we really want to solve the exact concentration? Do we really want to solve the exact, half-life of the contaminants? Why not? Because you are a scientist? Well, this is kind of, different level just between undergraduate and graduate level. Well, I just will teach you very simple theory of environmental science. And then, if you really want to do some more exact, solution, go graduate school. And then learn more techniques, numerical analysis, modeling, experiments. You can do, you can solve the environmental problems as you wish. This is very, very important. So think about the question here. On the other hand, some environmental reaction requires two reactants. For example, the reaction of the, just look at this. If some industry just emitted naphthalene, do you know what naphthalene is? This is polyaromatic hydrocarbons. Nuclear, we can put it nuclear here. Okay, David, what is this? You're not. Okay, what is this? Benzene. Benzene. All right. If you add one more here, what is this? Yeah, naphthalene. And if you add one more here, we call it anthracene. Or it has isomer. And what is this? Panthrene. And what is this? Figure out. And I don't know. Maybe styling or something, you know. Well, these are chemical compounds when the, some materials are burning. Fish is burning. And the vehicle actually, emits the combustion, chemicals, right? So all of the burning chemicals, burning compounds can produce polynuclear aromatic hydrocarbons, right? And also, this one is the main contaminants which can cause cancer in your lung when you smoke. Call it benzoic ion. Nicotine is not the chemical that can kill you. This can kill you, to make carcinoma in your lung. So all of these pHs emitted to the environment, it can react with, oxidant in the air, ozone, hydroxyl or nitrogen, which is very low concentration, and the concentration is relatively constant. In this case, what is the rate, or what is the rate flow the degradation follows? Well, as you can see, the pH is react with, let's say, hydroxyl. Then they can produce something. We want to know the concentration of pHs after reaction with this hydroxyl. Right. In this case, we can explain this with a little bit complex equation. Well, direction actually depending on these two chemical concentration. And then this is proportional actually. So make the equivalent relation. We want to put K here. Let's say K2. So here, the concentration itself proportional to the power 1 concentration, right? Here, the concentration actually decrease with respect to these two chemicals. So simply, you can put it as C squared. Right? So we call it this reaction, first order reaction, and we call it this reaction actually second order reaction. Right? But in fact, in the environment actually, we have another oxidant, ozone. We have another oxidant, nitrate. So the total weight was force. So how can you solve this equation? This equation, differential equation, well, simply you can have C equals C0 expression minus KT. Right? You can have it. And then put natural log each side, you can have simple solution. How can you solve this second order differential equation? Can you solve this? This is very simple, right? Actually. Can you get the analytical solution of the this second order differential equation? Can you get that? You can never ever have analytical solution without any assumption or any initial condition, boundary condition. So, well, starting the I think this is kind of smoking. Well, smoking is not a good habit, but this is the reason why you guys need to quit smoking. Smoking is just like breathing the exhausted vehicle gas, right? So there are many smoking poster here. I believe this guy, this is the patient who has cancer in his throat and some advertisement. Yeah. This is a little bit wow. Yeah. Oh, that. Yeah, this is just like if you smoke, it is just like you breathe the stack gas actually. And nowadays, if you just purchase a box of cigarettes outside of Korea, for example, at the airport, you can see the real, cancer patient image on the other side of the box. So don't smoke. Smoking and drinking is habit. So could be easily taken. Okay, this is just like the. Okay, and one thing that I can give you as a remedy, if you smoke, you really need to, have jogging or running, because here, any kind of PAHs you can have when you smoke. All of the polynuclear aromatic hydrocarbons, and then this emitted gas contaminants actually reacts with hydroxyl radical, as I already talked, and the ozone and nitrate in the air, which is around the 10 to minus 9 ppb, and these are very reactive, and it can degrade this chemical compound. So if you smoke, the chemicals actually, well, do you know the smoke is particle? It's particle. It is very small nanoparticle. So, well, you know, I really don't know you guys have asthma or not. When you have asthma, you can see the asthma patient inhaling the chemicals, right? So it usually have small nanoparticles in there, and the particle actually coated with the pharmaceutical chemicals. It widens his, the line of his breathing, right? So it can easily, effectively absorb on their system, breathing system, and it can extend their pipe actually of the breathing. Well, smoking is the same thing. The particle coated with tar and nicotine, and also these PAHs. So this is the reason why I call it, everybody call it drug. Smoking cigarette is drug. It is the reaction mechanism, or the mechanism itself is very similar to the drugs when you have asthma, right? So, smoking is actually doing the drug. But if you, do the drug, I mean smoke, the cigarette, as I already taught, do some jogging, to rejuvenate your system, actually. As I already taught, all of these heinous chemical, actually this is heinous chemical, because it can irritate you. Whenever you smell some, ozone, you can feel some kind of, uneasy feeling in your system. Well, but anyway, this can react with all of these polynuclear aromatic hydrocarbons, and it can degrade this chemical. So, if you smoke, the particle actually dissolve on your system, and then there is some well, as I already taught, the smoke is particle, nanoparticle, and all of the PAHs are well coated on the surface. And this particle easily dissolve on the cell, lung cell, actually. So there is kind of chemical transformation, chemical translation into the cell. The coated PAHs can be easily transferred to the cell. So this is the reason why we call it, smoking is drug. And you just stop the smoking. And if you have jogging, you can inhale all of these chemicals in your, body. And this chemical actually attack the chemical inside you. Oh, I really meant that. And then it can degrade the chemicals. So if you're smoking right now, and if you want to quit smoking, the first thing you should do is just run. Do jogging. Then you can quit smoking, and you can have better health. I bet that. All right. Okay. Well, anyway, this is the main reaction. But think about this. Think about this. This is the reactor to produce very useful chemical. So I just want to add chemical A and chemical B, and then make chemical C. Let's say C is very expensive AIDS curing drug. You are making AIDS curing drug, and here you put just 0.1 millimole A, here 0.2 millimole here. Let's say you can have 0.3 millimole of C. Then you can have C here. Well, if you put all of these chemicals inside, and theoretically you can have this amount. So, well, the degradation actually, dCA dt could be as a radical K2CaCd, like this, second order, right? But some, very excellent scientists just suggest if you put high concentration of B, well, you can have more and more ACE curing drug. In this case, well, you can have, let's say, 100 mole, right? So compared to Ca, concentration A, well, actually you have high concentration of B, right? Here. And you can put it as constant. Right? So this equation can be rewritten like this. This is A. So K to prime equals K to CD. Because CD is high excess amount of chemical, and it is constant, right? Well, this case is very similar to the degradation of this chemical in the air, because the concentration of ozone and hydroxyl radical nitrate, which is relatively low, but it is constant, right? So as you can see here, this is another, one. Let's do some more. Think about this is a pond with pure water, and then somebody just dumped the chemicals here, Ca, and we can actually, put the water as another, chemical, right? So you actually have maybe another Cc here, right? But the water content, concentration is so high, it is just like the constant, right? So here, curd is the contaminant. Somebody put the contaminant in the water, and the concentration change curd with respect to time equals actually K2 times curd water. But water concentration, it is so high, right? It's just like constant. So you can put it as K2 times H20 as a K2 prime. So you can have the same thing. But this is a little bit different. The K2 was, right, that's right. So in this case, you have second order. But in this case, technically, you can have first order. But actually, this is not first. So we just put Greek term dry, pseudo, and we call it pseudo first order. This is clear second order, right? So why do we want to use a pseudo first order rate law? Why do we want to do that? Well, because the environmental condition is just like that. Well, we don't have any choice. We need to use the pseudo first order. But what other cases do we want to use pseudo first order? Well, I already talked to you guys. Well, AGT is ACE curing drug. It was very expensive 10 years ago, actually. it is just like $10 per one, pill, actually. But if you just increase the concentration of B, if you can get more ACE drug, is there anybody who doesn't put the more chemical B into the reactor? So in this case, concentration B is much higher, so you want to do it slow first order, right? So for the engineering purpose, you want to put higher concentration of chemical. In that case, you don't want to use second order. You can follow pseudo first order. And then the good thing is you can easily solve the problem because you can follow the merits of pseudo first order. Understood? All right. So anyway, just focus on the naphthalene reaction in detail because the pseudo first order rate constant is, well, let's go back to the naphthalene. Reacts with hydroxyl and then it can be benzene or some any other things. But actually, the naphthalene DT can be K2 hydroxyl concentration, and also this naphthalene concentration like this. Right? But the hydroxyl is everywhere in the atmosphere, right? So we just put it as K prime and just naphthalene, right? Then we want to calculate this one. We can do this. Well, we just multiply K2 times and the concentration of hydroxyl, right? So here, by experiment, actually, you can estimate the second order rate constant K2 of hydroxyl, which is 24 times 10 to 12. This is number, Avogadro's number, right? And cubic centimeter divided by second. Right. Then here, the hydroxyl concentration in the atmosphere is usually 9 times 10 to 5 per cubic centimeter. Well, you may be a little bit complex about the number density. Well, if you just check the Avogadro's number one more and unit, volume, you can easily understand the number density. It is very useful, concentration unit. Then you can calculate it. K2 prime is 2 times 1/6 times 10 to 5 per second. So usually, if you just carefully look at the unit of rate constant or first order rate constant, K1 is usually 1 time. And second order case, it is concentration time. You can divide it from the equation. Then, using the rate constant, you can calculate the retention time of the naphthalene. So if you just put it K2 in the value here, and then just put the conversion vector from second to hour, you can have 13 hours. So once naphthalene emitted from vehicle, it can stay around the 13 hours. Then it can degrade to maybe benzene or any other chemical. But the important thing is, this is just a degradation of naphthalene. But we actually don't know its total products. It could be sometimes much more haze. So, well, I just recommend you, if you want to stop smoking, just learn right. So hydroxylglycol actually can degrade the tar or nicotine or benzoylpyrene, which is the most toxic chemical in your lung. So hydroxylglycol can degrade such heinous compound. Theoretically, well, the concentration of your lung decreased. But I can confirm the byproducts, the daughter products, by hydroxylglycol, it could be much more heinous. So during run, maybe much more toxic, daughter product can kill you. So it should be very, very careful when you have that. 이해되니? 네? 항상 나의 그 렉처를 갖다가 fully understand 하고 난 다음에 마지막에 나한테 조크를 하잖아.
예.
이해돼?
예, 열심히 하고 있습니다.
오케이, 간단하게 설명해 줄게요. 이게 딴 게 아니라 가끔 가다가 이게 한국말로 I'm very sorry to you guys. I think I already finished the lecture material today, but this is just for the Korean guys. 그러니까 여러분들이 담배를 피게 되면은 그러니까 이 니코틴이 똑같은 그 에스마 드럭하고 똑같이 여러분 폐에 아마 붙게 될 거고 그게 이제 그러니까 여러분 폐포로 들어가서 이제 그 암을 갖다가 이제 유발시키는데 근데 이제 내가 생각하고 있는 가장 그러니까 제너럴한 레머디는 뭐냐면 알기를 하면은 하이드로스라디칼을 갖다가 여러분 그럴 때보다 더 많이 수출할 수 있잖아요. 오존도 그렇고 그래서 아마 굉장히 농도가 높기 때문에 이 오존이나 하이드로스라디칼 자체가 그러니까 이 케미칼들, 렁에 붙이는 케미칼들을 부술 수 있을 거예요. 그래서 이론적으로 하자면은 그러니까 농도가 굉장히 다워지겠지. 근데 이제 문제는 뭐냐면 얘들이 이제 반응을 하게 돼요. 반응을 하게 되면은 이 반응 부산물들이 그러니까 굉장히 이제 powerful한 그러니까 이 톡식한 우리는 보통 이걸 도럴 컴파운드 왜 선 컴파운드라는 그러고 항상 딸 이렇게 도럴 컴파운드라고 그러는지 잘 모르겠는데 도럴 컴파운드들이 그러니까 주로 더 톡식. 그러니까 아마 내 생각에 이공주 선수가 이 계속 늘어가는 이유도 거기서 이제 실마리를 찾아보려고 하는데 하여튼 여러분 그 담배를 갖다가 아까도 얘기했지만 담배는 헤릿도 아니고 그러니까 드럭입니다. 드럭 똑같죠? 뭐예요? 에스마하고 원리가 똑같아요. 근데 이제 에스마 그 드럭을 갖다 발견한 사람이 담배를 보고 이렇게 따라 했는지는 모르겠는데 굉장히 스마트한 드럭입니다. 담배가 유스풀해요. 그래서 담배를 갖다가 안 피는 게 좋고 피더라도 조깅을 갖다 할 때 그냥 내 말을 갖다가 단순하게만 믿고 뛰게 되면은 그 케미컬 자체는 디그레이션이 일어나는데 또 새로운 도럴 프로덕트가 생겨서 일찍 죽을 수도 있다. 그러니까 여러분들이 조심해야 돼요. 그래서 담배는 피지 마세요. Any questions, comments? Okay.
에즈마가 뭐죠? 아.